day, everybody. We want to commence a new program called The Teacher. The Teacher. And what is the focus of this program? Is the teacher to bring out a relative change in character and learning in an individual and the society. So we have decided to embark on a continuous teaching that is likely to come in units. So today is Unit 1, and we'll be looking at a topic called differentiation. Differentiation is under the topic calculus, a branch of mathematics. So, we want to look at differentiation starting with what is called a gradient. What is a gradient? A gradient is the difference in the vertical axis and divided by the difference in the horizontal axis. So we can call mathematically now that a gradient is equal to difference in the vertical axis that can be represented by y2 minus y1 all over s2 minus x1. So if I look at a graph which ordinarily is drawn in this form, which means this is the x-axis and here is the y-axis. At this coordinate, we have a 0. To the right, we can have positive. So therefore, 1, 2, 3, 4, as the case may be. And to the left, you have minus 1, minus 2, minus 3, minus 4. In the y-axis, you also have the positive and the negative. As you go to the north, you have 1, 2, 3, 4, and so on. If you go down to the south, you also have minus 1, minus 2, minus 3, minus 4. So, for instance, we want to look at the gradient to find maybe y is equal to x squared. we want to find a differentiation of y equals to x squared. X is equals to 2x raised to the power x minus 1. So dy dx is equals to 2x. From the diagram above, we can take an illustration. Our normal diagram of the coordinates, and we have a straight line at theta. We can say that at this point, when we're looking for the gradients of this graph, like you know, this is the positive y-axis, and this is the negative y-axis, positive x-axis, and the negative positive x-axis, the negative x-axis. Assuming we have a point P, and this one another point Q, and then we are trying to find out the gradient of this very graph, which is actually what we call differentiation. Then, like I said in the above, that the gradient is equals to the gradient of PQ is equals to the difference, which is actually y1, y2, s2, xy. So, which will give us y2 minus y1 all over what? s2 minus x1. But if we are saying that we have a value attached to P and Q, which will denote the position of the axis of the y and the x. If we have P to have a position 3 and 9, it's what the coordinate is telling us, that y is 9 and x is 3. So if we have the position of the Q, and we say that position Q is 4 and 16, then what we are saying now is that in the position Q, y is 16 and x is 4. So from these values, we can calculate the differentiation or the gradient of position PQ. So if we put these values along these coordinates, it means that P is 3, 9 and Q is 4, 16. So I can say the gradient of PQ is equals to, from our above explanation, our y2 is 16 and our y1 is 9 all over our s2 is 9, our s2 is 4, and our x1 is 3. So therefore, If we subtract our values, 16 minus 9 is likely to give us what? 7. That's 10, 16. 7 all over what? 1. So what will we have in there is gradient is equals to 7. So the differentiation is equals to what? 7. We will stop here. We'll take the second unit in the next period. Thank you. Keep in touch.